Brian Maestri back, continuing with the Southwest Coastal Louisiana case study for the HEC risk assessment course. Now, as you can see, we're going to be looking at the uncertainty surrounding the depth damage relationships and content to structure value ratio, sometimes more usually abbreviated as CSVRs. And these are uncertainty surrounding inputs, the economic inputs. And starting on depth damage relationships, which is something where I've done a lot of work through my career on, depth damage relationships show you the percentage of damage or of the structure or its contents at each increment of flooding above the first floor elevation. If you can see on the slide in table 1, it shows a depth damage relationship. The first column is the depth, and the depth is always related to the first floor, and the first floor elevation is represented by a 0. That's right at the bottom of the door. The door is right at the door, so the first floor elevation. Now you notice we have a basement here, so damages happen before the first floor elevation, and you can see it happens, actually it starts 8 feet below the 0 damage, and then at 7 feet below you start damage, and then 6 feet you start more. And also you see there's a standard deviation which shows the amount of error associated with the percent damage at each of those 1 foot increments. That is to be distinguished, by the way, from stage damage relationships. Stage damage relationships are an output of the depth damage relationships in the inventory in your H&H. So the stage damage relationships is the total damages to the structures and contents in a community at each increment of flooding above the ground elevation as measured by the mean sea level or other datum. So there's some gauge out there. And now water is getting higher. And so as it gets higher, it gets to greater depths within structures, and some structures that didn't flood before now start flooding. So it's looking at the total damage relationship. Those are the stage damage relationships. That's different than the depth damage relationships. That's for a particular structure or category of structures. Those are inputs in order to get to the stage damage relationship. Depth damage relationships can be site specific. They're based on information in your particular study area, or they can be from outside another study area, and we'll look at that. And if you do that, then you should say, why are these appropriate for my study area? You should have some statements about that. And the court has developed generic national depth damage relationships. In fact, that's what's shown in table 1. It shows a 1-story with basement. There's an EGM 0401, which shows you the depth damage relationships for residential structures with basements. And later came out EGM 01-03, which showed residential structure damages with no basements. So that's what's shown on this slide. There are different sources of flooding, so your depth damage relationship should be somewhat related to what's your source of flooding. Was it backwater flooding, coastal, rainfall, rising lakes, alluvial flooding from a high elevation to a lower one? And in our district, actually, and I was a part of this, is developing depth damage relationships for 4 different type of inundation scenarios. A riverine or rainfall flooding, which is short duration, 1 day or less, freshwater from a river, from heavy rainfall. And then we have also riverine or rainfall flooding, long duration, where water is inside the structure for more than a day. We had a case like that back in May of 1985. It was freshwater flooding, and water was inside of structures for longer than 24 hours. Then there's the tropical type of flooding, which is dealing with our storm events such as hurricanes, in which it can be short duration, where water is inside for 1 day or less, and it can be freshwater type flooding, or it can be long duration saltwater, which is more typical of tropical type flooding, and it's greater than 1 day. And you can see at the bottom we have depth damage relationships for short duration freshwater, long duration freshwater, short duration saltwater, long duration saltwater. And of course the most damaging is long duration saltwater. Hurricane Katrina, water was inside of structures for weeks, and it was salt water, and which is more corrosive. So you're going to see higher percentages. But whatever depth damage relationships you use, you should say why they are appropriate for your study area. And that's something reviewers are looking for. In terms of the uncertainty surrounding depth damage relationships, we had a panel of experts develop our relationships. They were construction, repair, insurance, restoration, and these experts, we had 7 of them. They developed a minimum, a most likely, and a maximum value. Now you can take the 7 and develop the minimum and the maximum of those 7, or they can all provide that. There's different ways to get them, but you can see what is called a triangular probability distribution to represent your uncertainty. In the HEC-FDA model, we'll say, are you using a triangular probability distribution? And give me your minimum, your best estimate, and your maximum value. If you use a normal distribution, then it's going to ask for the mean and the standard deviation. Just to show you, I talked about saltwater relationships. This is what happened after Hurricane Katrina. The mold, our restoration experts kept telling us that, flooding might get up to 3 feet, but it could grow up to the ceiling. So your damages are beyond just the depth of the flooding inside of the structure once mold starts to build in. I know my parents' house looked just like this. It was amazing to walk into it after Hurricane Katrina, and after it'd been in several weeks, it felt like walking to a black and white picture. Everything was just black and gray. The contents mainly had floated out. They lost 100% of their contents, and they only had a few feet of flooding. The structure was badly damaged. So saltwater long duration flooding can be very damaging, especially with mold and mildew and the type of climates that you have down in Louisiana and Texas and areas along the coast. So the uncertainty there is for depth damage relationships. We talked about that. Now, also that usually goes along with it are the content to structure value ratios. Usually when you're developing the depth damage relationships, we also try to say, well, how much contents does a structure have? The way we did that, we had on-site surveys. We did for 3 residential categories, like 1-story, 2-story, mobile homes. We went and actually, this is not done anymore, but it was back when we did this in the 90s into the early 2000s. We had a person go around with a video camera and went through the home of volunteers. They got to keep their video. You couldn't pay them to allow this. And they recorded all of the contents. They got what was there and the value of it, and depreciated it, and then compared it to the structure value. What is this worth of replacing it and then depreciating it? And they got a content to structure value ratio. So they did this for the residential structures. They went and also went and do this for the 8 non-residential categories, such as like repair and groceries and eating establishments. And so we had 8 general categories, and I don't think you could take video cameras there, but they recorded the type of contents, depreciated them, and developed a content to structure value ratio. So you can use RS means or Marshall and Swift in order to derive those. The surveys we did back then were not random and not statistically significant, but to get any kind of primary information was pretty good. CSVA survey, showing you just CSVR surveys that we did for residential 1-story. You can see we did 10 and we got a 71%. So the contents was 71% of the structure value for a residential 1-story. And the standard deviation around that, the uncertainty, because we did 10 of them, so they weren't all the same. If you take that column of numbers, you get the mean and standard deviation. You can see it had a 0.25. So we've got the mean and standard deviation. We also did this for warehouses, and notice warehouses contain all types of things. It could be widgets, or it could be something very expensive, some type of machinery. And so it's a lot of variation in that. And so you can see the large standard deviation to go along with the mean. But the mean, the contents was usually worth more than the actual metal or steel building that it was in. But the point here is that there's uncertainty surrounding your key economic inputs, and that's incorporated into your analysis. That uncertainty then is used along with those parameters to calculate damages, and that's where we get the stage damage relationship. And so here you see how it looks in the HEC-FDA model. You got stages, and then you got the damages associated with it, and the standard deviation. The standard deviation is based on the uncertainty surrounding your first floor elevation, surrounding your content value, your structure value, and it's calculated. The model does that for you, and you can see the uncertainty bands off to the right.